We'll start in 1 minute. Today we'll be in section 11.1. This is the last section of the semester. In this section, we'll learn about the distance formula, which is how to find the distance between 2 points in the xy plane, and also equations of circles, which is closely related to the distance formula. So first, we'll review the Pythagorean Theorem. The Pythagorean Theorem has to do with right triangles. So any triangle with 190-degree angle is a right triangle. If we label the lengths of the two legs as A and B and the length of the hypotenuse C, then the Pythagorean Theorem says that if you square the length of the hypotenuse, that's equal to the sum of the squares of the lengths of the two legs. So C squared equals A squared plus B squared, where C is the length of the hypotenuse and A and B are the lengths of the two legs. So we'll find the distance between 2 points in the xy plane by using the Pythagorean Theorem. So we'll plot these points 1, 2, and 5, 4. We'll draw a y-axis and an x-axis. Okay, one of the points is the ordered pair 1, 2. And the other point has coordinates 5, 4. So this one is 1, 2, and this one is 5, 4. Well, with these 2 points in the xy plane, we can construct a right triangle if we draw a line segment that connects the 2 points. This is going to be the hypotenuse of the right triangle, and then we connect a horizontal line segment with a vertical line segment and form the right triangle. We can tell what the length of this horizontal side is. The horizontal side corresponds to the x-axis, and so the x-coordinates go from 1 to 5. So the length of this horizontal side is 4. Or you can think of it as, it might seem strange at this point, but think of this as the absolute value of 5 minus 1, where 5 is the x-coordinate of the vertex of the right triangle, and 1 is the x-coordinate of this point. But the absolute value of 5 minus 1 is 4. And then the length of the vertical side, we can see that that goes from y equals 2 to y equals 4. So we can see that the distance or the length of that vertical side is 2 units. But think of that as the absolute value of 4 minus 2. So the y-coordinate of this point is 4. The y-coordinate of that point is 2. So the absolute value of 4 minus 2, which is 2, gives us the length of the vertical side. The length of the hypotenuse is the distance between the 2 points. So I'll label the hypotenuse d to represent the distance between the points 1, 2, and 5, 4. And then we just apply the Pythagorean theorem to that right triangle. We square the length of the hypotenuse, so we're squaring the distance d, and then that's equal to 4 squared plus 2 squared. Then we do the arithmetic. 4 squared plus 2 squared is 16 plus 4. So the distance squared is 20. And then to find the distance, we just take the positive square root of 20. And then simplify square roots whenever possible. The square root of 20 is the same as the square root of 4 times 5. And so the distance is 2 times the square root of 5. So in general, we can do that. We can find the distance between 2 points in the xy plane just by applying the Pythagorean theorem to the appropriate right triangle. Okay, we can use the same idea to derive the distance formula between the points x1, y1 and x2, y2 in the xy plane. So for assistance, we'll just draw the x and y axes in the xy plane, and I'll pick a point and label this as the point with coordinates x1, y1, and then another point that has points x2, y2. And we want to find the distance between those 2 points. So we just construct a right triangle. We connect horizontal and vertical line segments. The x and y coordinates of this point, which is the vertex of the right angle in this right triangle, this has the same x coordinate as the point that's directly above it. So the x coordinate of this point is x2. So on the x-axis, this is where x1 is, and this is where x2 is. And the y-coordinate of this point is the same as the y-coordinate of the point on the same horizontal line. So the y-coordinate is y1. So on the y-axis, this point is y1, and this point is y2. Okay, so the horizontal side of this right triangle has a length that is equal to the absolute value of x2 minus x1. So we'll write the absolute value of x2 minus x1 to represent the length of that horizontal side of the right triangle. And the vertical side of the right triangle, since the y coordinates are y2 and y1, we'll say that the length of the vertical side of that right triangle is the absolute value of y2 minus y1. And we'll label the hypotenuse of that right triangle with the letter D. D represents the distance between the points x1, y1 and x2, y2. And then we just apply the Pythagorean theorem to this right triangle. And the result will be what we call the distance formula. So we square the hypotenuse, d squared, and that's equal to the square of the absolute value of x2 minus x1. Since we're squaring the absolute value of x2 minus x1, we don't need the absolute value symbols, because even if x2 minus x1 is negative, when you square it, it becomes positive. So we're going to go ahead and remove the absolute values. And then we add that to the other side squared. So this one is y2 minus y1 squared. And then the distance is the positive square root of this entire quantity, x2 minus x1 squared plus y2 minus y1 squared. So we really have two methods for finding the distance between 2 points in the xy plane. One is just constructing a right triangle like we did in the previous example, and then applying the Pythagorean theorem to that right triangle. Or you can memorize the distance formula. So one of the drawbacks of memorizing formulas, if you misremember one detail of the formula, then that leads to an incorrect answer. So it's okay to use the distance formula, but make sure that you apply it exactly the way it's written. Okay, we'll look at a number of examples where we find the distance between 2 points in the xy plane. So here's our first example. Find the distance between each pair of points and simplify the square roots. Find the distance between the points whose ordered pairs are 3, 2 and 7, 5. It doesn't matter which one you label x1, y1 and x2, y2. So we'll just apply the distance formula. The distance is the square root of, and then on the inside of the square root, let's focus on the x coordinates first. The x coordinates are 3 and 7. So one way to write this is in parentheses 7 minus 3 quantity squared. And then we add the square of the difference of the y coordinates. So the y coordinates are 2 and 5. So inside the square root, we can write the quantity 5 minus 2 squared. So always be careful that you're using the 2x coordinates and finding their difference and then squaring it, and identifying the y coordinates, find their difference and then square it. And then on the inside, you're adding those two numbers. Okay, so if you get it set up, then it's just a little bit more arithmetic. So 7 minus 3 is 4. So we have 4 squared, and then plus 3 squared, because 5 minus 2 is 3. And then we get the square root of 16 plus 9. Or the square root of 25. And the square root of 25 simplifies to 5. So the distance between those 2 points is 5 units. So that's all there is to it. Let's do the next example. Find the distance between the points whose coordinates are 6, -1, and -2, -8. So one way to memorize the distance formula is to write it down from memory. So the distance formula is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So the distance is the square root. Inside the square root, so with negative numbers, you have to be careful. The 2x coordinates are 6 and -2. So inside the square root, we can write the quantity 6 minus -2 squared. And then we'll add that to the other number. So now we focus on the y coordinates. The 2 y coordinates are -1 and -8. So inside the square root, we can write the quantity -1 minus -8, quantity squared. And then we do the arithmetic. Uh, 6 minus -2 is the same as 6 plus 2, or 8. So we have 8 squared. -1 minus -8 is the same as -1 plus 8, which is 7. So we get 7 squared. And then the square root of 64 plus 49. And 64 plus 49 is 113. So the distance between the 2 points is the square root of 113. The square root of 113 cannot be simplified any further. So we move to the next example. Work on this for about a minute, and then we'll compare answers. Find the distance between the points with coordinates -7, -2, and 4, 6. How many are almost done? Almost? Yeah, I got one answer online. Well, let's see if we're in agreement. So the distance inside the square root, focus on the x coordinates first. We have -7 and 4. So inside parentheses, we can write -7 minus 4 quantity squared. And we'll add that to the other quantity involving the y coordinates. The y coordinates are -2 and 6. So we can write inside parentheses -2 minus 6 quantity squared. Then we just do the arithmetic. The number -7 minus 4 is -11, so we have -11 squared, and then plus the other quantity squared. -2 minus 6 is -8, so we have plus the number -8 squared. -11 squared is 121. So we have the square root of 121 plus what we get when we square -8. The number -8 squared is positive 64. And then we get the distance is equal to the square root of 185. Uh, 185, that is equal to 5 times 37. And both 5 and 37 are prime numbers, so that means the square root of 185 cannot be simplified any further. All right, let's move to the next one. Find the distance between the points -9, 4 and 5, -3. So for practice, write down the distance formula. The distance is the square root of the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared. Okay, the distance inside the square root. First, focus on the x coordinates. The x coordinates are -9 and 5. So one way to write it, inside the square root, we have the quantity -9 minus 5 squared, and then plus the other quantity. So now we focus on the y coordinates. The y coordinates are 4 and -3. So inside parentheses, we write 4 minus -3 quantity squared. Okay, then the arithmetic. So inside the square root. The number negative 9 minus 5 is negative 14. So we have the number negative 14 squared, which we add to the other number. 4 minus negative 3 is the same as 4 plus 3, or 7. So we get 7 squared. And the number negative 14 squared, that's 196. Positive 196. And 7 squared is 49. And then we get the square root of 245. So let's see. 245 is equal to 5 times 49. And 49 is a perfect square. So that means the square root of 245 can be simplified. So rewrite the square root of 245 as the square root of 49 times 5. And then the square root of 49 is 7. So the distance this time is 7 times the square root of 5. All right, so make sure that you practice the distance formula enough. And if you're going to use the distance formula as a formula, make sure that you know it exactly the way it's written. All right, the next topic is circles. So we'll draw a circle in the xy plane that is centered at the point 3, 4 and has radius 2. And then we're going to find an equation for that circle by using the Pythagorean theorem. Okay, so let's see. So we'll plot the point 3, 4. Okay, so the point 3, 4 is right there. That's the center of the circle. And the radius of the circle is 2 units. So one of the points on the circle is right here. It's 2 units away from the center. Another point is right here. And then on a vertical line, one point is right there, 2 units away from the center. And then another point is right here. So what I'm going to try to draw a circle. So pretend like this is a circle. The center of the circle is the ordered pair 3, 4. And since there are infinitely many points on the circle, we can represent one of those points on the circle as having coordinates x and y. So we're going to find an equation for the circle by using the center 3, 4 and a representative point on the circle xy by using the Pythagorean theorem. Okay, the distance between the center of the circle and any point on the circle is called the radius. So this is the radius of that circle. But that's just the distance between the point 3, 4 and xy. And then if we construct a right triangle by connecting horizontal and vertical line segments, we'll find an expression for the length of the horizontal side and another expression for the length of the vertical side. And then we'll apply the Pythagorean theorem to that right triangle. And the result is an equation for that circle. So I'll redraw this right triangle so it's a little easier to see out here. So this point is the ordered pair 3, 4. And this point is the ordered pair xy. And so this point, the vertex of the right triangle, it has the same x coordinate as the point that's vertically above. So the x coordinate of this point is x. And the y coordinate is the same as any other point on this horizontal line. So the y coordinate is 4. So how do we represent the length of the horizontal side of this right triangle? We just focus on the x coordinates. The x coordinate of this point is 3, and the x coordinate of this point is x. So the length of this horizontal side is the absolute value of x minus 3. Now to get an expression for the length of the vertical side, now we focus on the y coordinates. The y coordinate of this point up here is y, and the y coordinate of this point here is 4. So we can represent the length of that vertical side by writing the absolute value of y minus 4. And the radius, r, is the distance between those 2 points. It's also the length of the hypotenuse of that right triangle. So we apply the Pythagorean theorem to this right triangle, and that is going to give us the equation for that circle. We know what the radius is, though. radius is given to be 2. So the radius is 2. So we apply the Pythagorean theorem to this right triangle. The horizontal side is the absolute value of x minus 3. The vertical side is the absolute value of y minus 4. And the hypotenuse is 2. Okay, so we square x minus 3. We add that to the square of y minus 4. And that's equal to the hypotenuse squared, 2 squared. And then the only thing that we simplify here is 2 squared. So x minus 3 squared plus y minus 4 squared equals 4. This is the equation for the circle centered at 3, 4 with radius 2. This is referred to as the standard equation. So one nice thing about the standard equation, we can tell by looking where the center is. The center is the ordered pair 3, 4. And we can also tell what the radius is. The radius is the square root of 4, or 2 in this case. Okay, in the next item, we're going to generalize what we did in this particular example. So this one, so what we're going to do is we're going to derive the standard equation of a circle using the same idea that we did previously. So find the equation of the circle centered at HK and radius R. So in the XY plane, if we have a circle, and if the center is HK, and then we have a representative point on the circle that we label XY, then we can construct a right triangle. If we connect the center and a representative point on the circle, then the distance from the center to a point on the circle is the radius R. And if we construct a right triangle by connecting a horizontal line segment with a vertical line segment, we can label the lengths of the two sides. The length of the horizontal side is the absolute value of x minus h. And the length of the vertical side of that right triangle is the absolute value of y minus k. Then to get the standard equation of the circle, we just apply the Pythagorean theorem to that right triangle. So the standard way to do it, square the binomial x minus h, add that to the square of the other binomial y minus k, and that's equal to r squared. Okay, so this is the standard equation of a circle centered at the ordered pair HK with radius R. So I'm sure it's pretty clear, but I'll mention it again. This is just the Pythagorean theorem applied to a particular right triangle. So application of the Pythagorean theorem. So if you know the Pythagorean theorem, you can use that to help you remember the standard equation of a circle. All right, we'll look at some examples where we simply write down the standard equation of a circle if we're given the center and the radius. Okay, if we're given the center and the radius, write the standard equation of the circle. So the center in part A, the center is the ordered pair 1, 3, and the radius is 2. So the x-coordinate is 1, so we write the quantity x minus 1 squared, and then we add that to the other quantity. The y-coordinate is 3, so we have the quantity y minus 3 squared. And then that's equal to the radius squared, 2 squared, which is 4. So that's all there is to that. In part B, same idea. This time the center is the ordered pair 4, negative 2, and the radius is 3. So the standard equation for that circle, so make sure that you keep the x-coordinate with the x variable. The x-coordinate is 4, so we have the quantity x minus 4 squared. We add that to the other quantity squared. The y-coordinate is negative 2. Y minus negative 2 is y plus 2, so we write y plus 2 squared. And then that's equal to the radius squared. Since the radius is 3, we get 9 when we square it. So there's the standard equation for that circle. Okay, in the next example, the center is the ordered pair 0, 5, and the radius is 4. The x-coordinate of the center is 0. We can start out by writing x minus 0 quantity squared, and then plus the other quantity squared. The y-coordinate is 5, so we have y minus 5 quantity squared, and that's equal to the radius squared. When we have something like this, x minus 0, we can just write it as x to the second, and then plus y minus 5 to the second equals 16. That is the standard equation. Before moving on to the next page, we'll just remind ourselves of something. What do you get when you square a binomial? The result of squaring a binomial is a perfect square trinomial. Exactly. So I'll just square this binomial. X minus 4 squared is x squared minus 8x plus 16. Note that since the coefficient of x squared is 1, if we take half of negative 8 and square it, we get 16. Right? That's the pattern of a perfect square trinomial when the coefficient of x squared is 1. Right? 1/2 of -8 is -4, and then when you square -4, you get 16. The other binomial squared, y plus 2 squared, is y squared plus 4y plus 4. The coefficient of y squared is 1, so that means if we take 1/2 of the coefficient of y, 1/2 of 4 is 2, and then square that number, we get 4. Okay, so now we're ready to look at the next page. Equations of circles don't have to begin in standard form. So here's an equation of a circle. It's not in standard form, but we can get it into standard form. So we'll rearrange the terms. We're starting out with x squared plus y squared plus 12y plus 2y equals -12. So rearrange it so that we have x squared plus 12x. Leave some space and then write plus y squared plus 2y. Leave some space and then write equals -12. So to get it into standard form, we have to complete the square twice. So we're going to add 2 numbers to both sides of the equation so that we get perfect square trinomials. So for x squared plus 12x, what number should we add to both sides of the equation so that we end up with a perfect square trinomial? Well, since the coefficient of x squared is 1, we take half of 12 and square it. Half of 12 is 6. 6 squared is 36, so we're going to add 36 to both sides of the equation. Whatever you do to one side of the equation, you have to do to the other. And then we're going to create another perfect square trinomial from y squared plus 2y. So since the coefficient of y squared is 1, we take half of 2 and square it. Half of 2 is 1, 1 squared is 1, so we add 1 to both sides. And then in the next equation, we can write the standard form. X squared plus 12x plus 36 is the binomial x plus 2 squared. And then we add that to y squared plus 2y plus 1, but that's equal to the binomial y plus 1 squared. And then on the right-hand side, -12 plus 36 is 24. 24 plus 1 is 25. And so we can identify the center. The center is the ordered pair -6, -1. And the radius is the square root of 25, or 5. Okay, the next equation for a circle, x squared plus y squared minus 4x minus 6y equals 23. Rearrange the terms so we get x squared minus 4x. Leave some space and then write plus y squared minus 6y. Leave some space before you write equals 23. And then we're going to create 2 perfect square trinomials. So we're going to add 2 numbers to both sides of the equation. So first focus on x squared minus 4x. Half of -4 is -2. When you square -2, you get +4. So we're going to add 4 to both sides. And then we'll create another perfect square trinomial. Half of -6 is -3, and when you square -3, you get +9. So we add 9 to both sides. And then in the next equation, we can write the standard form. X squared minus 4x plus 4 is equal to the binomial x minus 2 squared. And y squared minus 6y plus 9 is equal to the binomial y minus 3 squared. And then 23 plus 4 plus 9 is 36. So the center is the ordered pair 2, 3, and the radius is 6. Okay, we have a few seconds left. We can start the next one. X squared plus 10x plus y squared minus 8y minus 40 equals 0. So we can write x squared plus 10x, leave some space, plus y squared minus 8y. Leave some space, add 40 to both sides. And now we complete the square twice. So the first one, x squared plus 10x plus 5 squared is 25. So we add 25 to both sides. And then y squared minus 8y, half of negative 8 is negative 4. Square that, we get plus 16, add 16. And I'll just write one more thing, x plus 5 quantity squared plus y minus 4 quantity squared equals 81. Okay, we're out of time, so go ahead and sign in for attendance. Does that seem too fast, or does it seem to make sense?
It'll take more practice, but I think it's making sense.
Very nice. We're using a bunch of stuff we've used before, completing square and open square triangles.
It makes sense. I think I'm just gonna have to practice it more for it to really click.
You can always watch the video and put it on double speed, really speed it up, the variable time.
Okay.
I do that with a lot of videos that I like to watch. Speed up the time so it doesn't take as much time.
Thanks for the suggestion.
Yeah. Have a good one.